Welcome to my talk. It's titled Kotlin and Swift Convergent Evolution. And I'd like to thank Android Summit and Capital One for the invite to come speak here. It's my first time in Virginia, so that's cool. In discussing, I was talking about my talk with Eric Maxwell on Wednesday, and we actually decided between us that a slightly better title might have been Simultaneous Invention. Don't worry too much about the semantics of the difference. It's not super important, but I thought I'd put in a correction while I could. So a little bit about me to begin with. My name is Stewart Kent. I work at a software consultancy called Detroit Labs. We build awesome Android and iOS native applications for clients, and we also help clients build out awesome teams. You can find me, the easiest way to reach me is on Twitter at skentphd. If you want to tweet questions or comments or feedback about the talk, that would be appreciated. And I'm going to keep the handle in the bottom right-hand corner of most slides, so it's there throughout the talk. And I'll post slides and stuff a couple days from now. So first of all, a little bit about me and why I'm here and giving this talk. So I've been doing Android development for about 3.5 years now. And my first experience with mobile development at all was doing an Android and Java project for about 1.5 years. And after that 1.5 years, I was given the opportunity to work on an iOS project. And I don't know how much you remember or know about Swift, but this was around the early days of Swift, and this was the first all-Swift project within our company using Swift 1.2. And it was kind of an intense project. It was a first release, very tight deadline, so there was a very high-pressure learning environment, but I jumped in and got really excited and learned iOS and learned Swift. And then since then, I've mostly been back doing Android and Java work. So after coming back from that iOS and Swift project, one of the things that I would tell my colleagues was everything about Android development is better than iOS development, except for the language. That was the only thing that I really missed when I came back to Android and Java. But coincidentally, this was around the same time that Jake Warden wrote his white paper advocating for the use of Kotlin inside Square. And so it's been something that I've been paying attention to ever since then. Unfortunately, I haven't yet had the opportunity to write an Android client application using Kotlin. A lot of the code that we write ends up being handed off to clients, and so we have to abide by any rules and stipulations that their architecture review boards have put in place. But I've done a bunch of open source contribution using Kotlin. I contribute to the Expressivity track, which has been mentioned here a couple times as a good way to learn the language. And like Dan Liu, I did the Advent of Code challenges last year in Kotlin. So I'm kind of, I would call myself proficient with both Kotlin and Swift, but by no means an absolute expert. So I sat in Josh's talk yesterday, and I kind of stole some of the data that he collected at the beginning of that talk. He surveyed the audience and sort of figured out what the rough breakdown of experience with Kotlin was, and this is kind of how I quantified it. So my estimate is that about 90% of you have probably heard of Kotlin. About 50% have probably used it in some manner. About 15% have probably written Kotlin in a production in an Android application, and then maybe 10% have written Kotlin in production. So for me, the really important divide for this talk is this 50% that have used Kotlin and 50% approximately that haven't. So given the content of this talk, I would suggest that if you are in the 50% of people who have not used Kotlin before, that what you focus on here are some of the principles and the ideas that we're going to talk about, and worry less about the specific details of the Kotlin to Swift comparison, because I'd rather that you leave here super excited about Kotlin. That's the first step in this sort of conversion plan. And if you're in the 50% who have used Kotlin before, I would say you are probably going to be familiar with the concepts that we talk about here. That's part of the whole point of this, is that the concepts are going to be very similar. And so I would spend your time and focus on the Kotlin to Swift comparison and just seeing how similar those two things look, and thinking about how the stuff you know in Kotlin will translate well to Swift. So before we dive into the languages, I'd like to step back and look at Android and iOS a little bit. So as Kevin alluded to in his talk just now, there are a bunch of things that you as Android developers have had to learn about, things like lifecycle and networking and accessibility and how to handle background processing and how to handle security. These concepts translate identically to iOS. The method names may be different, but the concepts are exactly the same. And you've already put in the effort to learn this stuff. And some of the things that used to be a little bit more different between the two platforms have converged recently. So one example might be the fact that both both ecosystems have started to pay a lot more attention to deliberately architecting applications using things like MVP or MVVM. One of the biggest differences used to be building layouts and how complicated that seemed to be on iOS compared to how simple it seemed to be on Android. And there have been new components released for both ecosystems that kind of harmonize this experience. So where before we might have had to use auto layout for everything on iOS, they have now introduced this UI stack view, which basically plays the role of our linear layout. When we want an easy to reason about UI tool, we have one available on both platforms. And now Android has also introduced a constraint layout, which works very similarly to auto layout and is based on the exact same algorithm. So anything that you learn about constraint layout and any of the principles that you learn, they will work the same way with perhaps a few slight implementation differences in auto layout. And then the main focus of this talk is that the languages that we would use to develop natively on these two platforms have also converged. So I don't know about you, but what I know of Objective-C is that it's quite different from Java. And the pitch today is going to be that the differences between Kotlin and Swift are far less significant. So the claim I'm going to make is that it's never been easier for a native Android developer to learn native iOS development. And the calls to action I'd like to make are, as Android developers, I would like you to leave at least considering thinking about learning Kotlin because of the benefits that we're going to go through today. And then if you have done that, thinking about learning Swift and iOS. Now, the reasoning for this is, I have several good reasons why I think this is an appropriate thing to do. One is that it's really helped me learn how to communicate better with the iOS developers in my company. Before, we would talk about applications and have our own separate views as to how things were going to work, and it was based on an understanding of the frameworks and the capabilities. Knowing iOS and knowing Swift allows me to communicate a lot better across platform teams. It's also beneficial to step outside your comfort zone and think about what you've been doing on a day-to-day basis in Android development from a different perspective. So when I moved to iOS, I saw how they achieved similar goals in slightly different ways, and that allowed me to really critically think about how I was working in Android. And then finally, if for no other reason than these noble two that I've already described, you'll become a more valuable employee if you know both of these things. I've worked on both Android and iOS projects, and I'm able to work on either team, and I'm happy to do so. That means more money, probably. That's a good thing, I think. So let's now move on to the Kotlin and Swift portion of this talk. So Kotlin and Swift have strikingly similar principles and implementations, and I've picked a few of the ones that I think are most important and most demonstrate their commitment to the same ideals. And those would be a commitment to accessibility, expressivity, and safety. And these two languages were developed roughly simultaneously. I think Kotlin began development in 2011 and Swift in 2013. But as far as I'm aware, they were developed independently. So any similarities that have arisen have been because the ideas that they encapsulate are fundamentally good. They've drawn inspiration from similar sources. This is the simultaneous invention claim in this talk. So I'd like to look at all three of these sections that I called out: accessibility, expressivity, and safety, and sort of point out the similarities that exist here. So when we think about accessibility, both languages use what I would call a vanilla syntax. There's nothing super opinionated about the syntax that they've chosen for basic expression of the language. They've both focused also on gradual adoption via interoperability. So I think this is important for helping to onboard people who are familiar with the existing languages, Java and Objective-C. And both also have excellent documentation. When I go back and look at sort of the canonical Oracle documentation for Java and compare it to something like the Kotlin documentation, they're worlds apart in terms of both the quality of the examples that they use and also their focus on principles over specific practices. With Kotlin, we've seen already in Dan and Josh's talks that there's a semi-automatic migration, which is, I think the estimate was 60% of the hard work in moving from Java to Kotlin. In Swift, as far as I'm aware, there's no manual migration, so that's a little bit of a difference. But because you have interop, you can always start adding Swift to your code base alongside the existing Objective-C. So what I'd like to look at briefly now is this vanilla syntax claim and just show you what I mean by that. So the claim is that both these languages do nothing too weird, and the way I like to think of this is braces, not spaces, right? So I'm a fan of Python, and one of the things that people often complain about with Python is this whole space-based scoping, where indentation matters. So that's a deliberate choice that was made by the Python team, and regardless of whether or not you think it's ultimately a good idea, it represents a slight barrier to entry when learning the language. And I think that Kotlin and Swift have both done a good job of choosing conventions that don't represent that same barrier, that should look and feel familiar. So this is a simple assignment of a local variable or a property in both cases. The structure is the same. There's a keyword indicating what we're about to do, a name, an assignment operator, and a string literal. The only thing that's different between these two is the exact keyword used in both cases. If I wanted to declare a function, I use, again, very similar structure. I have a keyword followed by the name of my function, followed by my parameters, which in this case are parameter name, colon, parameter type. And then I express the return type of this function. In Kotlin, and this uses a colon, and in Swift, this uses an arrow for some reason. And then I have my brace-based scoping, and then I can return a string, and both languages have a fairly typical implementation of string interpolation that's being used here to insert the name into this string. And then if I want to call this thing, I can just write the method name, name the parameter that I'm going to specify a value for, and then in this case, pass in the string. So if we go a little bit above and beyond just basic assignment of things, one of the next things that we might think of as a super basic construct in a language that we're going to be using all of the time is looping constructs and conditional constructs. So this code is not, what this code does is not super important. It's counting spaces and letters in the string Android Summit. What I really want you to focus on is the looping that we have here, which is doing the calculation for us. So again, even if you are a Java developer who's never seen Kotlin before or never seen Swift before, my guess would be that you can look at this code and you could tell me what this does without too much effort. Again, the structure is extremely similar. We're missing parentheses in Swift. Those are optional when you're writing like a for loop or an if statement. But otherwise, things look pretty much the same here. And then the final thing I'd like to talk about is, in terms of the basic syntax, is how we declare things like contracts and how we adhere to contracts in our code. So in Kotlin, just as in Java, we have the concept of interfaces, and those interfaces can declare methods or, additionally, properties that a class that adheres to this contract must implement in order to fully and properly adhere to that contract. In Swift, we have the same concept. The name is different. It's called a protocol, but otherwise it's the same. You declare a list of the functions and the properties that anyone who declares that they conform to this protocol is going to implement. The syntax for making a class is identical, using the class keyword, and then the syntax for either inheritance or for adopting a protocol or implementing an interface is again the same. We use this colon to indicate that this class is going to implement the listener interface or conform to the listener protocol. And then inside each, I have to provide all of the method implementations that I promised I would. Again, these are the same as a normal function declaration that we saw in the standalone example previously. The only difference is that in Kotlin, I have to add the override keyword, and in Swift, that's not required. That's one that catches me out a lot. I often add my override and then need to remove it. So then if I have a class, what I'd like to be able to do typically is make an instance of it. So at the bottom of this slide, what we're now doing is instantiating an instance of this any class. We're assigning it to an any class variable, and in both cases, I am deliberately typing this as a listener just to prove that I can safely call this notify method when I know all I have is a listener. So the contract that we have specified is being honored here. The method invocation syntax is normal from my point of view. Again, if you're familiar with Objective-C, you know that things as simple as invoking a method are perhaps not as typical as you might find in other languages. So the takeaway I'm hoping from the last few slides is that it's fairly anticlimactic, and that's going to be kind of a theme for the talk because I'm trying to show you these two things are pretty much the same. So in the context of this talk, I want you to think of like an anticlimax as being a good thing, okay? So the next thing I'd like to look at is the expressivity that Kotlin and Swift allow us. So this list is long and certainly not complete. Both of them allow extension of closed source types. I think both Dan and Josh identified extensions as one of their favorite features of Kotlin, and it is by far and away my favorite feature of Kotlin and Swift too. Both also allow us to fluently operate on collections. They both provide the ability to use defaults in our method declarations to shrink API surface areas. They both allow algebraic data types. If you don't know what that is, that's fine. It's not going to be something that we deal with in depth today. They both allow first-class functions, and they both focus on amplifying the signal in your code and reducing noise. And here I'm thinking of noise in the context of boilerplate. So I haven't said it in the previous slides, but I've already shown you a few examples of these sneakily. In terms of amplifying the signal and reducing the noise, both languages offer type inference. So that means we don't have to explicitly declare a type unless we want to override the type that would be naturally inferred. There are no semicolons hanging around in our code unless we absolutely need them to separate statements on a single line. And both offer things like string interpolation, which is a small deal, but when you think about what you have to do in Java with the extra plus signs, and it's just a little bit slicker, a little bit smoother. You can focus a little bit more on the signal that you're trying to convey. So I'd like to look at 3 of these examples in a little bit more depth. That's extensions, fluent collection operations, and using defaults. And again, compare the implementations in these 2 languages. So if you're not familiar with extensions, if you're coming from a Java background and you haven't used or heard of Kotlin before, extensions are basically a way to add more discoverable utility methods throughout your code. They also allow more fluent expression of domain concepts. They're a big player in the completeness of the standard library that are offered by both languages. And one thing that I think is a little bit overlooked but is relevant to this talk is that you can use extension methods to minimize any differences between the standard library that you have available to you in Android and the standard library that you have available to you in Swift. So I'm going to look at one example which shows off discoverable utility methods and fluent expression of domain concepts. So I'm pretty sure everyone here has written some class at some time in Java that looks like this. So this is a password utility that I would be using to validate that a password is going to pass all of the rules that I am applying in my application. And the reason this class exists is because we don't own the source for the string type, and so I can't just go to the string class and write my own extra method in there and have that be available to me. So what I have to do instead is pass the string into this utility, perform some operations on it, and then give back a Boolean. So there's boilerplate associated with this. This is a whole new class. I have to make a private constructor to make sure there are no instances of this utility floating around. And then I have this static method that I'm supposed to call from my consuming code. So this is what usage would look like for that. I would say if password util.isValidPassword and then pass in my swordfish password. Then I can check whether a password is valid, and if it is, I can perform conditional logic, and if it's not, then I will do something else like show an error. So for me, the huge problem with this is not only that it doesn't read super well, it's that it's really not discoverable. So I have to know if I'm working in this code base that the password util exists and has an isValidPassword, and there's really no way for me to discover that without absorbing it through code review or having been the original author. It's really terrible for discoverability. And that's what extensions will solve for us. So this is an example of how we would declare this same functionality as an extension in both Kotlin and Swift. So this can be located anywhere. This doesn't have to be in a specific location. It can be in a file where you collect all of your extensions or string extensions. It supports scoping, so we can scope this to a particular piece of our application. And there are no parameters passed to this method now. What I'm going to be operating on is the string instance on which I call this method. So the syntax for saying this thing is an extension versus this is a regular method is, as you can see, slightly different in both cases. In the Kotlin version, we sort of prefix our method name with a string dot. And in Swift, we wrap it in this extension string block. But if you take away the extension-specific syntax, then what you're left with is just a regular method definition. There's nothing extra special which has to be done to make this method work. The only thing, as I alluded to, is that when you want to access the instance of the string that you're calling this method on, you can use the this keyword to do that in Kotlin and the self keyword to do that in Swift. Otherwise, super similar. And then the invocation looks exactly as it would do for any other method in your application. There is no way to distinguish at the call site that this is an extension versus a method that was originally in the class. So 2 main wins here. One is that this reads way better. So the English sentence that I'm writing here is, if swordfish is a valid password, that's way more readable than the whole utility thing. And the second is that because this is now a method on my string type, if I write the word swordfish and then type a period, one of the autocomplete options for me is going to be my extension method. It's way more discoverable. That's way less burden on you to know stuff about your application and instead to discover it as you go. Much better for collaboration. So the next thing I'd like to look at is collection operations. In both cases, these collection operations allow us to make more readable operations on our collections of objects. They're also much more flexible and maintainable, and they're also a little bit more robust. So you might say, well, in Java, we have streams already, which kind of promise some of the same things, and that is certainly true for Java 8+. On Android, you'll know that we have some support for Java 8 features, but right now, streams are only available for Min SDK 24+, and my guess is that not many of us are writing Min SDK 24+ applications just yet. So in the meantime, this is something that you should look into in Kotlin and in Swift. So I'm going to show an example now which highlights these three features of collection operations. So again, I don't know about you, but I know I've definitely written this kind of method in the past. This is taking a list, in this case a list of strings, and what I want to do is join it with comma space. So what I'm required to do in this case is I need to iterate over the indices of my list items. I can't use a for each loop because I'm going to have to be careful to make sure I don't add an extra trailing comma space at the end of my joined result. I only want the comma space to be in between elements. So I loop through these indices, and I say, OK, add the next element from my list, but then also make sure you check if you're the last element in the list. In this case, if you're not the last element in the list, you can add that comma space separator. But if you are the last element, then don't do that. So this is not robust in the sense that it's vulnerable to things like off by one errors. If I incorrectly write a less than or equals to here, or I forget that -1, then I'm going to cause a crash in my application. It's also not super easy to update this if I need to apply more operations later. So both standard libraries in Kotlin and Swift recognize that this is a common thing that we need to do and provide utility methods for doing it. And as far as I know, and this is certainly true in Kotlin and probably true in Swift, this is an example of extensions being used to complete the standard library and provide us with a more useful, more practical standard library. So in both cases here, this code completely replaces everything I had to write on the previous slide. And again, they're not the exact same method name, but if you type .join and look for the autocompletes, you're going to be able to find both of these pretty easily. We need to provide a separate parameter to the Swift version of this, but the functionality is extremely similar, and the syntax required to achieve this is extremely similar. So one more fake example, just to point out what I mean when I say we have these fluent collection operations. This is a fake example where you're gathering something like a list of orders from a customer, and what you'd like to do is a reasonably complex operation where you say, OK, I want to see the dates of the orders from 2016, but I'm paginating this, so I don't want like page 1 or page 2. I'm looking for page 3 of these dates of orders. So again, what the code is actually doing is not so super important for this particular talk. What's important is that you see how much of a correspondence there is between the operations that we have available to us and the way this code ends up looking. So the first thing we do to these orders is we apply a map operation which will take each one of the orders and pull the date string out of it. The only thing that's different between these two invocations is that the way we reference the item in the orders that we are currently operating on is by using the keyword it in Kotlin and the symbol $0 in Swift. Same thing goes for filtering. Filtering works exactly the same on both of these two platforms. Same thing goes for sorting. Same thing goes for reversing. Slightly different syntax when you want to drop the first 10 to allow pagination, drop versus drop first. And then again, slightly more different syntax for taking the first 5 and discarding the rest, or in this case, prefixing the first 5 and dropping the rest. So again, I want you to just look at this and be like totally underwhelmed by how much not new stuff I'm showing you if you're familiar with Kotlin. If you aren't familiar with Kotlin, I hope you're thinking this is pretty awesome. So the next thing I'd like to talk about is default parameter values. So I would think if people were to list in order their most exciting features of Kotlin when compared to Java, I think that the first two would probably make it onto most people's lists, and my suspicion is that default parameter values would not be most people's number 3. But I think it's an unsung hero of Kotlin and Swift. So in both cases, what default parameter values allow us to do is improve the clarity of our call sites, make it more clear what we're doing when we invoke a method. It also allows us to shrink and hugely simplify some of our utility APIs, and we'll see an example of this. It will allow us to replace the builder pattern that we have written many times over in Java I love the builder pattern. I just don't like having to write all of the code for it. It's a lot. And this also allows cleaner manual dependency injection. So this is something I use. I'm not my one guilty pleasure as an Android developer is that I've never really spent the time to learn Dagger. I do my dependency injection manually, and default parameter values allow me to do like really simple, clean dependency injection in production code, and then replace with specific instances of mock dependencies when I'm writing test code. So we're going to look at an example which illustrates these first two properties, that is improving call site clarity and shrinking and simplifying utility APIs. So this is a Kotlin standard library method called join-to-string, and it takes up to 6 parameters. It's the join-to-string that we saw a couple of slides back, actually, when we were looking at a previous example. So the syntax required to declare that there's going to be a default value for one of your parameters is just to write the normal declaration that you would for that parameter. So in this case, that's saying you can pass a separator, which is of type character sequence, and then just writing equals and a default value, which is of the appropriate type. Nothing too difficult about this. So then if I want to call this method and supply different numbers of those defaults, what will happen is if I specify a value for one of the parameters, that's the value that's going to be used. And if I don't specify a value for one of those parameters, the default value from that declaration is going to be used instead. So in join-to-string, what that means is if I call it with nothing at all in terms of customized parameters, what I get is the default behavior, which is to give me back my iterable separated by comma space. However, if I didn't like the comma space separation and I preferred a big ampersand instead, I can provide just the separator, and it will give me a space ampersand space separator throughout my string. And then finally, I could also do something like construct a tuple representation by saying, OK, I would like a custom prefix and a custom postfix when you join this string. Use everything else default, so we still get that comma space separation. But now our join string has a parens at either end to make this look like a tuple. So I have a question now for you to make sure you're still awake. How many join-to-string methods would it take to replicate the functionality offered by this Kotlin method in Java? Any guesses? Yeah, somewhat, yeah. What did you say? 64? Yeah, how do you know it's 64? Yeah, right, so there's 64, which is 2 to the 6th power, because you can think about going through these parameters, and there are 2 choices for each parameter. There's the version of the method that does include it, and the version of the method that doesn't include it. However, there's a catch to the question, because there always is in a talk, which is that there are 2 to the 64 methods, but you're also going to run into name collisions if you try and do this, because 4 of these parameters have the same type. And so when you look at a Java method is distinguished by its name and the type of its parameters. So some of these are going to collide, and what you'd end up writing is join to string 2 or join to string 3, and that for me ruins an API and makes it way less discoverable again. So again, a huge win in terms of reducing that API surface in the code that you need to write. So this exact method join to string doesn't exist in Swift. In the previous slide, we just used join. So what I did here was write my own join to string extension, just to show you an example of using extensions to minimize any differences that do exist between Kotlin and Swift standard libraries. So in this case, I was able to write a join-to-string function which has the exact same signature and uses the exact same declaration for providing a default value. So again, one of my parameters, separator of type string, I just say this equals a comma space by default, and then if I don't provide that value at invocation time, the comma space separator is what's going to be used. So to see that in action, these are the same 3 examples that I used in the Kotlin version of this. No parameters at all give us a comma-separated string. Providing a separator of space ampersand space uses that to separate my values. And then a tuple representation can be achieved by using a prefix, postfix, and specifying nothing else. The last thing I'd like to talk about is safety. So both of these languages are statically typed. Again, as Java developers, that's perhaps not super exciting. If you're coming from Objective-C, where it used to be a little bit more Wild West and typing was a little bit less popular, this is a huge win coming to Swift. Both languages force developers to confront nullability. and force them to confront mutability much earlier in their thinking. From there, it deviates a little bit more. Kotlin has immutable views of immutable collections, and it also has data classes with synthetic copy methods to encourage you to use more immutability in your code. And Swift actually has full-blown custom value types. So the only example I'd like to show here is forcing developers to confront nullability, just because I think this is such a huge win and a huge change when you're building an application and trying to build a stable product. So we're going to look at explicit nullability. So in Java, this is how I would declare a string typically. By default, there's no nullability information provided. So this S1 variable may contain an actual string, or it may be null. And when I call something like s1.length, by default, I have no idea whether that is going to work or not. This could evaluate to a number, which is probably what I want, or it could crash my entire app. That to me is an unnecessary danger, kind of scary, but we do it all the time. And the way we do it is by holding in our heads and reasoning through our code constantly when things could or should not be null. So the null reference has famously been called $1 billion mistake. And so, what we have in Java now to help us work around this issue is annotations. So we can annotate something and say, OK, for the purposes of the compiler checks, this is something that I'm going to declare to be non-null, or something I'm going to declare to be nullable. So this is opt-in information about nullability. And what we get when we use this is warnings in our code. So if I call something like s1.length here, because I've hinted that s1 is going to be non-null, this is presumed to be safe, and so there's no warning given to me. On the flip side, if I call s2.length, this is something that I've hinted at as possibly unsafe, and what I will get is a warning in my IDE. But I will only get a warning, no compile error. If I do a null check on S2, then it is assumed that this is now safe-ish, modulo concurrency issues, and so again, I won't see a warning here. So if any of you, I hope all of you were in Kelly's keynote yesterday, one of the things that she talked about was this idea of removing the barriers that we have in between us and making better choices. And to me, the fact that opting in is required to nullability handling in Java, that is a barrier to making a better choice. By default, you don't have to handle nullability, and so the lazy side of us means that we don't tend to do it. But there's a better way, and that's what Kotlin and Swift have embraced, and our friend Jake Wharton here has put this nicely and succinctly. The $1 trillion mistake, he said, was assuming that the $1 billion mistake is because of the mere existence of null, and not the absence of support for null in the type system. So support in the type system is exactly what both Kotlin and Swift have done. So in the case I'm showing here, S1 has been declared as type string in both cases, and S2 has been declared as type string ? In both cases. So the difference between these is that S1 is something that is allowed to contain non-null values only. And anything declared as type string ? Or optionally of type string is something that is allowed to contain null values. So now if I was to try and take S1 and assign it to null, this would not compile. This goes beyond the level of just a warning in your IDE. This is not a thing you can ignore. This is now a compile issue. On the flip side, if I've said, it's OK, I know this is something I'm declaring to possibly be null, if I try to assign that value to null, everything's good. So this is built-in safety. This is removing that barrier, the opt-in barrier to handling nullability properly. And then the same thing goes once we've opted into this. Once we've got this nullability information in our variables, it also helps us when we try and dereference those things. So in this case, if I was to try and take S1 and call the .first method on it, this would compile fine because there is a guarantee that this thing's not going to be containing a null. On the flip side, if I call S2.first, this is not going to compile in both cases because there's no guarantee anymore that that might not be a null value. There are ways to work around this. I can say explicitly null check on S2 and then unwrap it, saying, OK, I've checked that this is not null. And I can just say, fine, forcibly unwrap the value and give me whatever string is contained. Or I can do things that we've seen more examples of this from Josh and Dan. Again, I can do things like optionally perform operations, so only call this method if the value is non-null. And again, since this is the last slide of code, look at how underwhelming this is. Like, these two things look exactly the same. They're extremely similar. So final thoughts. Kotlin and Swift are fundamentally similar, and I mean that in terms of the principles that they have chosen to embody and promote. And above and beyond that, they're functionally similar in the sense that when you use them, they look and feel the same. So concepts that you're familiar with, you don't have to figure out how to translate into new syntax. The syntax is so incredibly close that you're almost all the way there anyway. And so what I'd like to circle up with and end with is that learning and developing with both is extremely viable. And I also want to say, thanks to the interesting scheduling we had here today, this is definitely not the only option. There are cross-platform solutions like Doppel, like React Native. For my particular case, working in a shop where we do a lot of native Android and a lot of native iOS, this is a very sensible path for me and a very reasonable path for me to choose. But just be aware this is not the only solution. However, if you're already into Kotlin and looking for a way into iOS and Swift, it's never been easier to make that transition. So if you're interested in actually doing this, here are some tactics for you. As I mentioned at the beginning of the talk, I help maintain the Java and Kotlin exercism tracks, and I know there's a Swift track which is at least as active as the Kotlin one. So if you're interested in sort of small, well-formed exercises to teach you these fundamentals, that's a great place to go. I highly recommend the official documentation for both languages. That's not something I say for all programming languages or concepts, but in this case, they're really both great. This blog post, Swift is like Kotlin, does an even more extensive and detailed breakdown of this piece of syntax looks like this piece of syntax, so you really get a very fine-grained comparison of how the two appear. And then if you're lucky enough, like me, to work in a company where we do native iOS and as well as native Android, one of the things I like to do is just spy on PRs for projects that I'm not necessarily on. I get to watch and I get to learn and I get to see the back and forth commentary that goes on. And then if you're feeling brave, you can also just start contributing to those projects. So I've worked on Android projects in my company, and as I find issues in my app, I might see the same thing in the iOS app, and I will submit a PR and say, this is something that I'm still working on and learning. I'd appreciate any feedback. And for the most part, people are super happy that you've taken the time to do most of the fix of an issue for them, and they'll definitely be glad to give you feedback and help you get it to the finish line. So with that, I'd like to say thanks again to everyone for coming, and thanks to the organizers for having me. And you can reach out to me on Twitter, or if you have questions, just come see me after the talk. I'll be hanging around for the rest of the conference as well.